Hi there. So today we'll continue from where we stopped the very last class. So I promised that I was going to talk about power factor, and resonance in this class. So we'll start with power factor first. So I remember that the very last class we looked at impedance, okay, and then we saw how to calculate the impedance for each connections or for each circuit. So we said that for the RL circuit, for instance, we are just going to, if you remember that diagram very well, we are just going to take the upper part of the diagram where this is R and this is XL. So we said that the impedance Z here will be the square root of R squared plus XL squared. Okay, this makes sense. Okay, and then we said that for the RC circuit, we are going to take the lower part. This is XC. Okay, and this is still R. Okay, so we have that the impedance Z here is the square root of R squared plus XC squared. Okay, so and then I remember we also said for the LC circuit, we said that it is just the straight line. Okay, because this is the middle, we have the XL here and XC here. So we said that the impedance is XL minus XC. It's very simple. And then we said that for the RLC circuit, okay, for the RLC circuit, okay, so we said that we are going to combine the XL and the XC together, so that we have XL minus XC, and then this is R, and then so we have this, and this is Z. So we said that the Z here is the square root of R squared plus, open your bracket, XL minus XC all squared. So this is basically what we discussed in the last class. So in this class today, we are going to look at power factor, as I've said. So power factor is actually cos phi. So what exactly is this phi? Okay, so looking at this diagram that I gave you the earlier on, the previous video or the previous class, we said that this is R. Okay, so that this is XL. This is XC. So we have that the angle between the resultant, okay, and the horizontal and the resistor, okay, is what we call the phi. Okay, we can also have for this guy too. This is the this is the Z, okay, this is Z here. So that means this place is also that's not theta, I just wrote theta, sorry. This place is also phi, okay. So when we take the cos of this angle, and also cos of this angle, then we have the power factor. So this is very simple. Don't forget that in mathematics we have that cos theta is adjacent over hypotenuse. Okay, so now for this upper part, which is the, obviously, this is L, this is R. So for this upper part, which is the RL circuit, isn't it? For an RL circuit, we have that the power factor, which is cos phi, okay, will be given as what? So what is cos phi? That's adjacent over hypotenuse, that is R over Z. Okay, so obviously the constant rule is actually that power factor is always given as R over Z, regardless of the circuit you are doing. So which is R over, so you can define your Z now. Your Z is square root of, isn't it, R squared plus XL squared. So that is the power factor for that guy there. And for the one that is underneath, which is the that's an RC circuit, isn't it? RC circuit. Okay, so we are going to have that the power factor for the RC circuit, which is the cos phi, okay, will be R over Z, obviously, because the adjacent obviously is this R, and Z is the hypotenuse, which is R over, open your square root, that's R squared plus XC squared. So that's power factor for that. Okay, so what about an RLC circuit? For an RLC circuit, okay, we have that the power factor. So I'll draw the RLC circuit. Don't forget the simplified RLC circuit that we drew the other time. R, this is XL minus XC. Okay, so and then this is the Z. This hypotenuse is the Z. So we said that the angle between this Z and this is the phi. So we have that cos phi, which is the power factor, alright, is adjacent over hypotenuse, which is on Z, so which is R, which is R over Z. Okay, so that is R over, so what is Z? Z is the square root, okay, of R squared plus XL minus X whole squared. So that is the power factor. And so the power factor is just like a value, that actually determines the real power, that is being consumed or that is being used up in an AC circuit. So that's why you see there are different types of power when it comes to AC. We have the apparent, we have the real power. So now the apparent power multiplied with the power factor gives us the real power. Okay, so that is basically the major essence of this power factor that we are talking about there. So that said, now we are still going to solve questions on this. Okay, I'm going to the next video. I'll be dropping a video on questions. So just going to solving questions, because you'll be like, what's the essence of all these things? We are just learning them or not. So you'll be able to use it to solve questions. Okay, so the next thing I want to talk about is resonance. Okay, so we are just talking about the mathematics basically. So resonance in an AC. Okay, in an AC. So that's what we're going to talk about in the very next class. Actually, I want to talk about resonance in an AC. What does it mean for us to actually talk about resonance? What happens in resonance? So I'm just going to give a very grand principle that in an AC circuit, okay, in an AC circuit, resonance occurs. Okay, let me just quickly write that out. Resonance occurs, okay, when the value of our XL equals value of our XC. So this condition is the condition for resonance to occur. So once we have this condition satisfied, okay, we can actually say that resonance is occurring at that moment. So what is the mathematical implication of this? What are we looking forward to when this happens? We're going to answer that in the very next video. And then wait, before you go, ensure you subscribe to this video. I know that you must have been learning one or two things from our classes so far. Just subscribe, like, share with your friends. Let them also benefit from the same. Look at this simple AC circuit has been broken down to the simplest form. Just by some diagrams, all those formulas, you don't have to cram them, just you know them by heart now. So hit the like button, hit the subscribe button down there, okay, and yeah, I'll see you in the next video. Thank you.